Okay, we'll go through the questions of 2020 November paper for Advanced Program Mathematics, paper 1. So we'll see the questions and the solutions underneath. Now, as you see, the questions ask possible solutions in R, real numbers, okay, and without using calculator. I think that's important. Without using calculator. So what we should do, first of all, we have to leave the absolute value part alone. So take 3 other side divided by 2 and so on. So you get 4, and inside is either -4 or 4, and then that makes e to the power of x is 9 or 1. And how do you find it? It is ln 9. X is equal to ln 9 or ln 1. ln 1 is equal to 0. So that's how we got the answer, and you see the mark allocation for 7 marks. And if ln x is 3, x is e to the power of 3. And actually there is no way that we cannot use, we have to use calculator here. That's a bit contradiction with the question, because otherwise you have to leave your answer as e cube, and that's it. Okay. Now determine a and b if it is given in this form. Now what do we have? A plus bi divided by 5 minus I is half minus half I. So it's basically writing in this complex number, the fraction, the standard form. So we divide and multiply with its conjugate, and once we do that, it's basically simplifying, and once we do that, the denominator will become 5 minus I times 5 plus I. That will be 25 minus I square. That's how we got 26. You see, 25 minus I square will be 26. And then the absolute value, instead of -1, instead of I square, we will write -1. That's one thing. And hence, we will end up this. What is that? 5a minus b divided by 23 is the real part. Okay, that's my real part. And then plus 5a plus 5b divided by 26 is the imaginary part. So if you just make denominator same, instead of 1 over 2, we can write 13 over 2. That's not a problem. So then numerators, 5a minus b is 13, and a plus 5b is 13 as well. So solving simultaneously, we'll get the values of a and b. That's it. Okay, 1.3, the quintic formula. Because it has rational coefficients, that's important. That's how we can just write the others. If there is a 2 plus I, then we get 2 minus I. That's okay. And then if we have 1 plus root 3, then we'll get 1 minus root 3, and 1 plus root 3 comes together. So since we know the other two, we actually know 4 solutions altogether. 2 are real, 2 are imaginary. Okay, complex. Then 2 are complex numbers, these 2, and the other 2 is, the 2 plus I and 2 minus I are the complex numbers, and 1 minus root 3 and 1 plus root 3 is the it's the conjugate third theorem and third complex conjugate theorem, and the third conjugate theorem gives us this condition. So we can write all the factors since we know the solutions, the roots. The roots means solutions. So we can write all the factors and just open the brackets. So from the first two, we will get a quadratic one, and then from the other two, we will get another quadratic one, and their product is the answer, obviously. Okay, it's an 8-mark question, which is nice. And you see the coefficients are all real. That's the condition was given at the beginning. And now this question 2, I'm not going to spend a lot of time. If you can just pause and go through the question, it's basically substituting the values. But the first thing is leave t as the subject of the formula. So make t the subject of the formula. That means leave t alone. And so we will substitute r with 0.1 as well. That's r, the interest rate in the formula. So we will leave t alone and substitute r with 0.1. And the triple itself is basically, this triple itself is the relation between A and P. So we will have P, the original investment, and it will become 3P. So A is equal to basically 3P. Okay, that will triple itself. So in the formula, when it is A over P, that will give us, you see, that will give us 3, that in the solution. So yeah, that's it. And this time making R the subject of the formula, it's like the same process as making T, and substituting the other values. You invested 500, then it become 900, and the duration is 3 years, so all the values is given. You just leave that alone, leave R alone, and substitute the values and get the answer. Okay, now mathematical induction question, the famous one, always. It's you see, they either ask proving a formula or divisible or a multiple of a number. So this time it is a divisible by 3. So what are the steps? First step, we will write, we will check for n is equal to 1 and just write it works for it. The second step, we will assume, so the keyword is assuming. For k, it's basically just rewrite the formula. And last step, you substitute with k plus 1, check for k plus 1. Now assuming idea is this: whenever n is k, so k cubed plus 2k is divisible by 3. That means it can be written as 3 times p. See, that's the important part here. So k cubed plus 2k can be written 3p. So instead of k cubed along the process, we can just substitute 3p minus 2k. Okay, because in the next step that can be done. And in the final step, instead of n now, we will write k plus 1. So k plus 1 cube and 2 times k plus 1. We have to open that brackets carefully. You see, it's the k plus 1 cube, and then, so that's 2k plus 2. So after simplifications, we'll get the answer. And don't forget writing the conclusion. That's the last step. Okay. Now first principles question. Now there are two types here. One is the questions like f of x could be given in the past papers. You'll see something like 3x plus 5 or that type of thing. So that will be the fractions and stuff. Then we will become, instead of x, it will be x plus h we will write, you know that. And now this time, instead of x, we will write x plus h. So it will be, for f of x plus h, so it will be 1 minus x minus h. Okay. And when there are roots, we must multiply and divide by its conjugate. So what was the conjugate in the previous question with the search we had it? So you see the minus is the sign between them is minus. Why is it minus? Because in the formula limit h approaching 0, what is it? F of x plus h minus f of x and divided by h. This is the formula. Now that minus is over there. So to be able to get rid of the roots, we will multiply with and divide with the conjugate. Okay, that's the conjugate. So that step is for the that's rationalizing denominators or numerator here, whatever, rationalizing idea. Okay, so yeah, you can just pause and see this algebra for more details in the solution. Question 5 is there equations and nature of all asymptotes. So we will write the asymptotes. What we know about the asymptotes here, first of all, whatever makes denominator 0 is vertical asymptotes. Okay, limit x approaching infinity is the horizontal asymptote. Horizontal asymptote is y is equal to limit x approaching infinity. And this will be what? Because the coefficients are same, we can say y is equal to, the leading coefficients, leading degrees are same. So it is x squared, and that's x squared. So the coefficients of x squared and x squared is 2 divided by 1. So that's how we get 2. So that's our horizontal asymptote, just looking at the coefficients. And looking at denominators, what makes denominator 0 when we factorize? That's x is equal to 6 and x is equal to minus 1. There are two of them. So we got 2 of these here. And yeah, that's all. Prove that the function is strictly decreasing. Now, strictly decreasing, so decreasing is all about first derivative always negative, not even 0. So that's what we are going to do. We have to find the derivative, and derivative of this is actually quotient rule. What is derivative of a over b? A prime b minus b prime a divided by b squared, remember? But we will just focus on the numerator because that's important. That's when it becomes, or actually we will just show this thing somehow always negative. Okay, now let's have a look at the solution. What do we see? So when we take derivative, multiply with numerator, the other derivative, it's lots of these opening brackets and stuff. So at the end of the day, our aim is to show the one above is something always negative. So it has a turning point, I can just say, has maximum at x is equal to minus 3 over 2, minus 3 over 4, minus 3 over 4, and it is what? Negative 81 over 4. So it's always negative because its maximum is there. So, or basically we can just say has range y is equal to less than or equal to minus 81 over 4. So this is, the numerator is always negative. Now look at the denominator. Denominator always positive. So numerator is always negative, denominator is always positive. That means this fraction is always negative. Since it is always negative, you see that's what is written. Since it is always negative, what we say? We will say strictly decreasing. So that was the aim. So the idea is to show, just rewrite the first derivative into the form that you can prove it's always negative. So something always negative divided by something always positive is always negative. Okay, just explain it like that. Okay, 5.2 is a rational function given oblique asymptote is there. Vertical asymptote is x plus 2. That means that's in denominator x plus 2. Sorry, vertical asymptote is x is equal to minus 2. So x plus 2 is the must be the in denominator. You see, it could be like it could be 2x plus 4 or 3x plus 6, whatever. But x plus 2 is fine. However, to find the numerator, how do we get oblique asymptote? It is when we divide, so that must be x squared because that's linear, that must be something square. So that's when we write, so the expression will be like this: y is equal to 2x plus 1 plus x plus 2, and that's the remainder. Okay, I was going to write k, but since it is written remainder here, so that's our expression is. Now, to be able to rewrite in the form of x plus 2, that's why we will multiply with x plus 2 and 2x plus 1, and that will be a remainder plus something. Since it is not given, I just write r here. Answer is not unique. C must be bigger than. Marks awarded for thinking rather than working. You see, your marks will be awarded for thinking. That's interesting. Huh? Good. No x-intercepts. So no x-intercept idea is, since it is oblique asymptote, we should have, okay, when we substitute x with 0, you get a value. That's not a problem. Just to find, okay, how can we figure out? So these are fine and we can open that brackets. So I'm just thinking a possible value for, you see it is written 13 here. So it is not a unique C, that's explained here. It's not a unique C. Like we can write 14, 15, 17. So the only problem is writing something more than 25 over 8. So why or what would be the problem for that? So because of that no x-intercept idea. No x-intercept idea meaning numerator must have discriminant negative. Okay, that means no real roots. No real roots. So what is denominator at the moment? What do we have? Like I have this. What is numerator at the moment? I just want to explain a little bit more this one. So if I have x plus 2 times 2x plus 1 and then plus, let's say, k. It's something. We don't know. It's the remainder. So it's basically 2x square plus 3x plus 5x, sorry, plus 5x plus 5x plus 2 plus k. Now discriminant to be 0 is what? We must have a is equal to 2, a is equal to 2, b is equal to 5, and c is equal to k plus 2. Now let's just think now. What is that? B square minus 4ac. What must be less than 0? We know that. So what is b square? B square is 25 minus 4 times 2 times k plus 2 is less than 0. So we got 25 minus 8k minus 16 minus 8k 2 times k, yes, 4 times 2 times k, so b square minus 4ac. Okay, it is 8k minus 16 is less than 0. So 8k 25, so it is 7. Let's take it other side. Minus 8k is less than minus 9, so k will be more than 9 over 8. Okay, I think this question, they say 25 over 8, but it must be anything more than 9 over 8 should be accepted. Okay, but you see, they don't really want to see this. You look at the memorandum. As long as you write any value satisfying that condition which has no x-intercept, it's accepted, so you still get full marks. So I just try to explain that last part. Okay, first two it was fine. Oblique asymptote. So for the first two information, I can just write that condition and making denominator same and stuff. That's almost done. The only problem is choosing that constant part. Okay, so question 6. It's a piecewise function given, and graph is given as well. Pay careful attention to notation. That's why I will leave you with the memorandum. Be careful what to write. There is a removable discontinuity. So we will classify. It's 6-mark question. Just looking at the graph, I can say there is a discontinuity here. There is a discontinuity there at -4 and at 1. But -4 is the removable one, because limit exists, however it is not equal to f of -4. That's how we write notation is this. Okay, however when x is 1, it is jump discontinuity because limit doesn't exist. Limit f of x approaching 1 doesn't exist. From right it is approaching 5.5 something, from left it's approaching 8. So since there is no limit, it's jump discontinuity. So that's the notation we have to write in that way. And 6.2, if a and b are differentiable x3. So when x is 3, it must be a critical point. When x is 3, look at that. You see the function is changing. So before 3 it's a parabola, after 3 it's a straight line. So however, looking at the graph, this part is a parabola, but then it becomes a straight line. So it looks like a smooth continuity. So it looks like it is differentiable. However, we have to prove that. So to prove this, we will just focus on this part of the function. So since it's differentiable, it must be continuous. So when we substitute 3 to the left and right, they must be equal. And after taking derivative, when we substitute 3, even then they must be equal. So there are two conditions we will check. So when we substitute 3 to the left and right to the original function, they must be equal. So the left side, when we substitute 3, this gives me what? 1.5, because -4.5 plus 9 plus 6 is 1.5. You see, it is equal to 1 on the right. So when we substitute 3a plus b is 1.5. This first equation, because of being continuous. Okay, that's for being continuous. Now for the differentiability, I will check the limits for derivatives. You see, so I have to take the derivatives first. You can actually just write aside this derivative is what? Derivative of that it is minus x, that's all, and derivative of this is a. So these are the derivatives, minus x and a. So what do we get? Minus x. So when you substitute x with 3, that will be minus 3. So minus 3 is a. Basically, a is minus 3, you see. Because that's what we said. These must be equal at x is 3. So when x is equal to 3, that means a is equal to minus x, which is minus 3. That's what is done in the solution. So you find a first. After a, we can find b. Okay, just be careful with the notation. Not a lot of details, but at least those writing limits approaching left, right, that's the notation, what they mean. Pay careful attention. Okay. Question 7 looks like an implicit derivative question, and 0, 2, and 0 is a point on this graph, and we need to find the equation of tangent. So what we know is basically a derivative is the gradient, which is dy over dx, and that's what we have to get first. Now, how do we get derivative? It's the implicit one. So it's the product rule, the quotient rule. So like term by term, derivative of x squared is 2x. Now x times sine y, it is the implicit one, and the product rule. Derivative of y is y prime. Derivative of 2x is 2. You see, so it is 2x. So it's only the middle one is the product rule, and be careful with the implicit derivative idea, because derivative of sine y is cosine y prime. You see, that's, just be careful with that. I can just write here sine y derivative is cosine y times y prime. Be careful with that. And here we even have a product rule, so it's like a times b. Remember, it is a prime times b plus b prime times a. So that is what is done here. We take derivative of each term. We already said derivative of x squared is 2x, derivative of y is y prime, derivative of 2x is 2. These are fine. So this is the middle one. You see, that's what we were explaining. This is the derivative of x times sine y. Now, once we got that, it is the most important part now. Our aim is to leave y alone, because that's the derivative. So there is y prime here, there is y prime there, so we will combine them and leave that alone. So y prime is written in terms of x and y, so we will substitute 2 and 0, because that's the point. So when you substitute 2 and 0, you'll find that specific gradient at that point for that tangent line. Then it is equation of a straight line. Okay, the most important part is that applying implicit derivative in this solution. Okay, now looks like an application question here that we have. There's a story they are telling us. We can pause and read whatever. The distances are 50, 60, 70. Radius is 60, so CB is 10. Anyway, so it looks like what percentage of field is infected. So we will find the shaded area and divided by the whole area, isn't it? And times 100%. So what is shaded area? So shaded area, from the sector we will subtract the triangle area. So from the sector we have to get the angle at center, and then that's cosine rule. Remember, you can say 70 square is equal to 50 square plus 60 square minus 2 times 50 times 60 times cosine alpha. And basically leaving cosine alpha alone, it's what we have written in the question. They left cosine alpha alone, and then cosine is given 1 over 5. So then cosine inverse 1 over 5, it must be in radians, is 1.369 whatever. So be careful, it must be in radians. And then since we got the angle now, it's the formula, as you see, area of sector minus area of triangle. So that's the shaded area. Shaded area is 995.296. So this divided by the whole circle area will give us the percentage. Okay. So applying cosine rule, then area of sector minus area of triangle. So we got the shaded area. Then we are done here. Okay. Now question 9. They define us even an odd function. That's good. So odd function is like cosine x. You see, sine x is odd function. I can give an example. For example, sine x is odd function. Why? Because sine negative x is equal to negative sine x. It's odd function. And cosine x, as a good example, is an even function. Why? Because cosine negative x is cosine x. Okay, so or a parabola x square is an even function as well. Anyway, so they are given and they intersect at a. Good. So we have the integral of f from 0 to a, and that's 0.75, and g 0 to a is 0.6. So what is f minus g? Okay, so f minus g, basically which one is above? F is above. You see, from 0 to a, they are asking this shaded area. You see, f minus g is the area between the dotted line and from 0 to a. So it's basically their difference. You see, 0.75 minus 0.6 is the answer. That's it. Now if we have minus a to 0, so since they are even functions, they are even or odd functions, so we must be careful. You see, they actually give the graphs. So that means, for example, for f, that is minus a, and then for g as well. So since that area for g is same, that is 0.6, but for f that will be negative 0.75. I mean, area is same, but the problem is because it is below x-axis, so that will be like that. So then here I will be having a negative answer for integral because it is below x-axis, then a positive answer. G is positive, it doesn't matter. So that's negative 0.5. And when you times f with 2 and g with 3, the answers, like we can take 2 and 3 out as the constant values. So since minus a to a, integral f of x will be 0. Why? Because this is negative 0.5 from minus a to 0, and from 0 to a is 0.75. So when we add them, it will be 0. That's why, because it's an odd function. That's why. So that is 0. You see that 0, this 0, but the other one is we will double it up, because minus a to a, we can show it here, that is 0.6, that's another 0.6. So there are two 0.6 together. So it is 2 times 0.6, and then we'll get that answer. So that step is important here. And the absolute value of f, we know what to do. It's the left side is copy paste to the right. So then 0.75 from 0 to a, it will be repeated. Okay, it will be times by 2. So 0.75 times 2 is 1.5, because it is just the left side is reflected about y-axis to the right. Okay, now absolute value graphs and equations are given. So finding a, p, and a, q values. So pq, remember, that is what? That's the salient point, and the salient point must be minus p and q. So what is salient point for g? G is that it is 2 and which one is g? Oh, g is the other one, sorry. G is the other one, that is 4 and 9. So this is 4 and 9. So that means what? Minus p is equal to 4. So p is negative 4, and basically q is 9. That's all. Q is 9. Okay. Now, using the graphs or otherwise, solve this equation. So how can we use graphs? Think on it. We will just rewrite these equations with the formula, like what we have, f of x, we already know, but when we know g of x, now g of x is negative 3x minus 4 plus 9. So we have negative 3x, so it is positive 3, you see. So we will take it other side, and I need 9, 10, there is 10 here. I will split as 9 and 1. So I'll take 9, I'll keep 9 here, and I'll take one other side as minus 1. So when we have that, I will get this line. So this line is basically f more than g, because left side is whatever f is, and the right side is whatever g is. So f more than g. Now we can just look at the graph. When do we have f more than g? F is more than g. It is before they intersect. You see, before they intersect, which is x is less than 1, and after they intersect the second time. So it is here f is more, and then g is more. We don't take in between, and after 6. So before 1 and after 6 is the answer. And determine 1 to 7 the integral. So it's basically area under curve, you know that. So the area under curve of g from 1 to 7 is area of that right angled triangle. We can just find the area using normal methods like area of a triangle. What is base? Base is 6. What is height? Height is 9. So we can times them and divide it by 2. So area 1 to 7 g of sorry, that is f, huh? Which one is g? G of x integral 1 to 7. I'm checking again. Integral 1 to 7. Yeah, why it isn't split it as 1 to 3 and 3 to 7? I think they mean the question wrong, because this solution is for f. For g it's kind of easy, but for f they got it for f because they split 1 to 3 and then 3 to 7. So that will get one negative answer, one positive answer, then that's minus 1 and 8, so answer is 7. So this question is solved for f. Okay, so I'll just make the correction. It must be f of x. Okay, correction. This solution works for f of x. Because if it were for g of x, the answer will be quite easy, because base is 6, height is 9. So 9 times 6 divided by 2. Answer is 27. Okay. Base times height divided by 2. So 6 times 9 divided by 2 is 27. That's the area for g. But for f, the solution is here. You can see. Okay. Now Newton's method question, a famous one again. We ask to find the turning point. So it's the first derivative. You see, our original function will be the first derivative. So our original function is when first derivative 0. So we know the function. We'll take its derivative and make it 0. So this is our original function. We have to solve when does it become 0. So that's my function. So I need its derivative, because in the formula which is given, what is that? Xn plus 1 is equal to xn minus f of xn, and then divided by derivative of f of xn. So this f of xn here is the one above, is the first derivative. Okay, that's my let's say f of x, and that's my original function, derivative of the original function I mean, and then derivative of that is basically second derivative of the original function. So here we are given f of x, but we will take as original function, I mean for the Newton's method, our function is its derivative, because we will solve for it. The rest is using calculator, writing the answers, because that's what they want. They want you to show this iterative formula. So this is very important, and writing the first few answers are very important, and final answer is 5 decimal places. That's important. So initial approximation is 2. That's already given. That's a good thing to know. Okay, so it's a nice example for Newton's and Raphson method approximation. You can have a look and see. Now this one, when the area bounded by the curve. So as n approaches 0, remember, if we have infinitely many rectangles, we'll have the exact answer. So from 0 to 2. So if n goes to infinity, denominator, wherever n is in denominator, that will be 0, because 4 over infinity is 0, like that. So the answer will be exactly minus 8 over 3 and plus 12. So that will be the correct answer, like exact answer. We will just add up the numerical values, because here, so that's explained here, as n goes to infinity, 4 over n square and 4 over n, 4 over 3n square and 4 over n, these are approaching 0. So you'll just take minus 8 over 3 and then 12. That will be the answer. So that is the answer under the curve. But the question is shaded area. So for shaded area, so that's a rectangle now. What is the height, or how do you find this rectangle? And so we can subtract that area. So we know the height. I mean the base. This is 2, and that height when x is 2, that is 6. So it is further given that f2 is 6. Yeah, we know that this is 6. So 6 times 2, this whole area is 12. So we will subtract 28 over 3. How do you get 28 over 3? Just adding those numerical values. Okay. Now more integral questions. First one is kind of k method. You can use k method and say that's my k. But you see it says no, need not to be shown, so you can just write the answer and get 6 marks. But with the k method, it is k is 3x squared plus 7, so our dk is 6x dx. And then so instead of how can we write this now? I'll write the integral. There is x, there is k cube. Instead of dx, we'll write dk over 6x, so the x's will cancel. Then 1 over 3 will come out, 1 over 6 come out. K cube will be k to the power of 4 divided by 4 plus c. So that's how we got 6 and 4 is 1 over 24, and then k to the power of 4 plus c. So when you substitute k, the original value, so we'll get this answer. K is something to the power of 4, 3x squared plus 7 to the power of 4 divided by 24. Plus c. Okay, the next one, this is UDV method. Like remember, integral of u times dv is equal to u times v minus integral of v times du. So it's all about choosing u and dv correctly. I mean in the formula sheet it is given at f of x and g of x. So if I say my u is x, so du is dx straight, and dv is the remaining part, is e to the power of x dx, e to the power of 2x dx. Then v will be 1 over 2 e to the power of 2x, because remember we will, because of the chain rule. Now u times v is basically x times 1 over 2. That's the first step. And then we will have a small integral when you write the, when you write this formula, we still have an integral, but that integral an easy integral. That's why we are choosing this method. Otherwise, it will not be possible without using this UDV method. Okay, integration by parts. Okay, now this question looks like we have to apply partial fractions because this is x cube. I mean x squared, that is x. So we have to factorize this and write it is a over b. So you see the methods are not shown here, but I can just write 3x minus 5 over x minus 3 and x plus 1 is equal to a over x minus 3, and then plus b over x plus 1. So how do you find a and b? We will just rewrite this thing. We will say 3x minus 5 is basically equal to a times x plus 1 and plus b times x minus 3. So you substitute x with minus 1. You see, all these things are like just skipped. So for x is equal to minus 1, left side is minus 8, and the right side is minus 4b. So that's how we got b is equal to 2. You see, it's just written 2 in the solution. And then if x is equal to 3, right side is 9 minus 4, it is 4. And if x is, it is 4a. So we got a is equal to 1. So we got a and b just like that, you see. So once we write these partial fractions, because denominators are just linear, the answers will be ln, derivative of ln. Okay. So 2 or ln, absolute value, don't forget absolute value, and don't forget c. Alright, so these things we have actually done for that step in between. And the last question, finally, we have a volume question. So that's a function tangent x from 0 to a. You see, tangent is infinity to infinity, remember, but just 0 to a, and a is less than 90, we can see that. Now when it is rotated about x-axis, what is the volume formula? If you remember, volume is pi times integral a to b square of f of x, square of the function dx. Now this time our function is tangent, so we will square tangent x. So tangent x derivative, do we know that? Is there any such a formula? We just need to remember one of the identities, because tan x square, there's no tan derivative of tan x square, but it can be written as secant square x minus 1. Okay, because of the trigonometric identity. So that's the tricky part in this question. You see, thinking of derivative of integral of secant square is easy, because tangent x derivative is sec square, and derivative of tangent x derivative is sec square. So integral of sec square is tangent x. So for 1, okay, integral of 1 is x, because derivative of x is 1. So that's easier than thinking about tan x square, because once you make that substitution, as you see, the solution becomes quite easy, and you just substitute a, 0 and a, and find the answer. So again, the most important part in this question is to think about converting tan square into sec square minus 1. From then, that's an approachable, nice question here. All right, I hope that's fine.